Assalamu alaikum. How are you, Yasir?
I'm fine. How are you? Well,
I'm I'm good. Let me introduce myself. My name is Yabatul Zedi, and I'm working as a AI engineer at Accelerate. So this is our mock interview. So let's start. Let Introduce yourself, Yasir.
yes, as you know, my name is Yasir, and I'm working as a software engineer and also in the domain of AI and ML, and have background in AI and machine learning as well. And I have like around 2 to 3 years of experience.
Okay. So let's start our interview. So this is the mock interview, and explain, Yasir, what is machine learning?
So, machine learning is a subset of AI. So, AI is in the larger sense, we can call everything AI, but AI stands for machine learning. So, with machine learning, there are basically uh, two major types, regression and classification within machine learning. And within training a model, we can also have three types of learning, like supervised learning, unsupervised learning, and reinforcement learning. Uh, with like we say, like ChatGPT is an AI tool. So ChatGPT, what does ChatGPT do? ChatGPT predicts next word. With machine learning, regression, and classification, with classification we can predict like if it is a cat or not a cat. That would be binary classification, and then there will be multi-class classification. So within multi-class classification, we could say whether it is a cat or a dog or a mouse or whatever. With regression, we can predict linear values or time series values. Within time series values, we can say we can predict like whether we can predict the stock market price or we can predict the next word. When we say we can predict the next word, that is what is actually happening in ChatGPT or any large language model, which is trained on a very large subset of data and which can predict next tokens. So ChatGPT is nothing but a type of regression model within machine learning, and that we can call AI.
Okay. So, what is neural network?
A neural network is a type of machine learning model where we it's basically an architecture where we have a input layer, a hidden layer, and an output layer, and we have nodes. We call each node a neuron, and then we make a circuit of it or make a path where we do like a forward path and a backward path to update the weight. So each node or each neuron would have a, let's say we assign it a name called X. So for neuron number one, it would be X1 plus multiplied by its weight. So we would assign it some value which we call its weight. That would be W1, and we would add some bias. So that would be plus the bias would be to reduce the bias in the output. For example, if 2 plus 2 is equal to 4 and we know it is 4, and the model is giving output is 2 plus 2 equal to 3, with the additional bias, hypothetically we could push the answer to 4 to a line answer, since the model isn't calculating or isn't based on a formula, it is learning and updating the weight. So yeah, that would be a brief overview of a neural network. If you want, we can have like we can draw a diagram and we can go for change it there.
Okay. Explain the architecture of CNN.
A CNN, so CNN is a type of neural network that is used for image recognition or image classification. So with CNN, we have different layers. So on average, CNN would consist of, we would start by applying a filter on an image. So an image is nothing but pixels from 0 to 255. So if we have an image could be represented in vectors, and vectors could be represented in matrices. With each matrix, we can apply a filter, and that, like, for example, if we have a matrix of let's say 8 by 8, we can apply a filter of 2 by 2, and then we can do something called sliding on the vector or stride. We can set the stride size, and we can move the filter on the main matrix. And with the matrix, with the filter, we would do convolution. The convolution is basically multiplication of matrices. Once we do matrices with one stride, we would get one value. suppose 8 by 8 matrix would be reduced to a smaller matrix. Then we would do something called polling. So polling is could be of many types. For example, there could be average polling or max polling. For each of the matrices that we get, we would take the highest number of value in max polling or average value in the matrix and make another subset of the matrix. In that matrix, we can then apply a flatten layer to convert into a 1D vector. So that is how generally a convolution neural network works. By convolution, we just mean multiplication. For example, a convolution neural network like an AlexNet or LeNet are examples of convolution neural networks.
Okay, nice. Uh, can you explain any machine learning model like decision tree?
Yeah, with decision tree or yeah, with decision tree we use it to basically make like we do in K clustering or KNN. We find nodes or we find output data where we can have which would have similar features. So there is a formula for it. There is an information gain, and there's another metric which we calculate, and based on that we can, for example, if we have a like a data in rows and column form, we can then apply decision tree to sort of categorize values into it, into like nodes, and we can compare those nodes and then put them into separate categories. And based on that, we can make prediction whether the input value would fall into which cluster or a group of values. And that would be a the overview of decision tree.
Okay, so what is the difference between loss function and optimizer?
Loss function is used to calculate the difference between the true value and the predicted value. For example, we are training a model, and for example, we know that we have the input is 2, the model with the output is 4, and the model is giving output of 3. To calculate the difference between the actual value and the predicted value, we use something called a loss function. Example of loss function could be cross entropy loss function. And then with optimizer is basically what is used to update the weight. Optimizer is also called sometimes the update tool. So in model, when we do an iteration, we assign random weights to a model. After that, we calculate the loss, and then we do a backward pass to calculate how much we need to update the weight. Then in order to update the weight, we use the optimizer.
Okay, so mention the any name of optimizer that you used in your
Ad-
previous work.
Adam is something I could recall right now. Adam is an optimizer, stochastic gradient descent is an optimizer available PG. And
Can
yeah, these are
can
the
uh, can you explain difference between Adam and gradient descent?
no, I'm not able to recall that. Could you give me a hint or something?
Okay, so Adams and okay, okay, leave it. Um, explain any loss function, like how mention the name of loss function that you used.
Yeah, I'm able to recall binary cross entropy and categorical flexibility. I'm not able to recall the exact formula used for both of those, but I know that binary cross entropy could be used to calculate the it is used when we are doing some sort of binary classification, and categorical is used when we are doing a lot of multi-class classification. But at the root of the loss function, we are basically calculating the difference between the actual and the predicted value. So the roots stay same, the formula or the name, the system or the method can be different change from the time. And
Okay, in optimizer, do you know about gradient batch descent?
no, I'm not able to recall. Gradient based different.
Okay, so um, okay, let's move to our next session. I'm sharing your problem. You have to solve.
Uh, this I have
Yes.
a question with me.
Sorry. Okay, just
I said
mention.
I let me paste it somewhere. Yes, if you can go over the question and give me an overview of the problem.
Okay. This is the problem. Like, just a minute. The problem is about the airport connectivity. Like, uh, a country has an airport connection that are directed at source. Each source allows people to fly from one airport to another, but not necessarily in reverse. The aviation authority want to analyze the cyclic connectivity of the network. A set of airport is considered connected if from any airport in the set is possible to reach every other. Since we have to find the connectivity like from one airport point to every other airport point.
Yeah,
So this is the
so
problem.
yes, so by my understanding, we have a we have different locations or different areas where there are airports located. What we want to do is to find the airports which are connected to each other by these streets. So if I'm on airport A and airport B, if I can go from airport A to airport B, and if possible I can go from B to A as well, but that is not a requirement. But if I can go both ways, then that is what we want to find the airport which are connected to each other. But from A, I cannot go to C, and from B, I cannot go to C directly, and that means that is a separate airport. So I think this is a graph problem. So uh, if you have idea about graph, uh, there are two types of graph structure. So for example, there is a directed graph and there is an undirected graph. For example, in a graph, there are two nodes and the two nodes are connected to each other, but we don't know
Hmm.
where, like, we don't necessarily know the direction of the node from which we travel. So, for example, in a binary tree, where we know we have a left node and a right node. In a graph, we don't necessarily know the direction, uh, but we know something like the edges. So, but in a directed graph, we know the direction of the node from which one node can go to another node. So, for example, we can say that this is node A and this is node B. So, we from node A to node B, we know that we can go to node A to node B. And how we would call the edge of the node A that node B is connected to node B through its edge. Right? Does it make sense?
Okay. Okay.
Yeah. So, for example, if I in a graph structure I have uh, let's say from a few nodes, for example, zero, 1, then 2, then 3, and then let's say uh, 4, 5, 6, and 7.
Hmm.
To be honest,
All right.
let's type it in. So 1, 3, 4, 5, 6, and 7. So if I want to like make the connection of each of the node, so let's say we from node 0, we can go to node 1, and from node 1, we can go to node 2. And from node 2, we can also go to node 0. So
Oh,
if we even reverse the direction of each of the nodes, we know that we can travel from each of those to each of them. So uh, this is how we know that each of them are connected, uh, which we call a fully connected component.
yes, all right.
In a directed graph. So this would be a directed graph model. Whether in a directed graph we have a concept fully connected component, and this is used in Kosa-Raju algorithm. So just like we have different algorithms like lifestyle algorithm and TSD, like we have different data structure. Within data structure we have different algorithms, but this is type of algorithm that is used to solve this type of problem. So if we find a group of nodes where even if we reverse travel, uh, we find a way that each of them are connected, we would say that this is the airport from which we can fly to any other airport and we would be able to circle it back. So then we can say that we can travel to from 2 to we can travel to 3, and from 3 we can travel to 4, and from 4 we can say that we can travel to 5, from 5 we can travel to 6, from 6 we can travel back to 4, and then we can from 4 we can also travel to 7. So let's the 7, or let's say our problem 7 is disconnected from the set. So 7 has no outgoing edges. So there is a thing called outgoing edges in the graph.
Okay, very nice.
So yes, so is it making sense? So for example, in our structure, in our case, uh, we can say that this is a fully connected component. Then this is a fully connected component. If I can shape it, and then
Okay,
for
got it.
7, we can say this is not a fully connected component. For 7, 7 would be separate, and then we can say that 3 is also not a fully connected component, since we cannot circle back to it. So for 5, for example, if it was connected to 3, we would say that this is also fully connected. So in our graph, we need to find the fully connected components in the graph, and in that way, we would be able to find the number of airports or number of connections. So in our case, the output would be 2, which would tell us that the number of like the networks. If we have basically 2 networks by which we could, if we travel at 0, we can travel at any of those connected airport. So the way we do it is we travel from node. Let's say we start from node 0, then we go to node 1. From node 1 we go to node 2. From node 2 we know that we can go to node 0 as well, and from node 0 we can go to node 1. So we know that this is a fully connected component. Then we go to 3.
Like,
From node 3 we can go to node 4, and then from 4 we can go to 5, 6, and 6 to 4 as well. So we can go back, and we would, when visiting a node, we would mark each node as a visited node, and which then we would go to 7. But then we know that from 7 it has no outgoing edges, so this is a separate component. So then we would
yes,
so do you have idea about stack data structure? So stack is a
yes,
like a data structure. So we have like it's the stack is based on the principle that first in is last out. So we could use a stack here,
yes,
and after visiting each node, we would go in reverse and put the last element in the stack. So, for example, we visited 7, then we would put 7 in the node. Then we would go back. From 7, we would go to 4. To 4, we can go to 5, and we can go to 6. So, each of these node we visited, so we can put them in the stack as well. 4 and all the way back to 2, 1, and 0. After going there, we would start popping the nodes. So this is for the we can conceptually we can explain, but this is for how we will do it in code. So when doing in code, we would like begin again, and then we would go start from 0, and we would pop each visited node after it has been visited from our possible scenario. So we would go to 0, we would pop the 0 from the stack, and then we would go to 1. From 2 we can from 2 we can calculate that we can go to 0 as well, but 3 and 3 as well. So we know that from 1 traversal here is possible and traversal here is possible. So we would pop 1 and 2 from the stack as well, and we would mark this subset as a fully connected component. Then we would go to 3. From 3 we can only go to 4. So we would then pop 3. So 3 would be a separate component. Then we would go to 4, and then the same theory would apply here. And therefore, we would
Nice.
get fully connected component here, and then the 7 would be a separate component here. So, for example, this could be Australia, Canada, and New Zealand, and this could be Pakistan, India, and Bangladesh. So we would be able to find the fully connected components. And in code, it obviously these would not be numbers, so we would have to then map them to a dictionary. So we could, for example, like map to, to map them to numbers. Then we would so point number 2 would be traverse the nodes. Then we would mark each visited node. Then step 4 would be to traverse back, pop each visited node, mark connections with multiple edges, and then uh, separate or like store each fully connected component in a variable or something. And I missed a step where we would like somewhere here to store elements in the stack, and then we would pop them. So yeah, I think the code part that would be done really if we conceptually we have the understanding of things. So there may be a mistake in my understanding of the thing, but yeah, this is how we would approach the solution for this problem.
Yes, this is fine and good efforts that you made. So, okay, Asir, any question from your side?
No, that would be it. It was a good session. So thank you for your time.
Okay, let me share your feedback. Your answer was strong, overall strong. Uh, you have a great technical and problem solving knowledge, and you have a great skills. One area you want, you have to work on it, providing more structural and detailed examples of from your experience. Like explain with the examples, like when you like CNN in disciplinary, you should mention one or two examples, like real life examples. That was a point. You have to work on it, and overall, all your efforts are good. You perform well. Thank you for your
Okay,
time.
thank you.
Okay, any question?
No, I think that would be it.
Okay, thank you so much for your time.